Hi everyone, welcome to Chemoholics, your one-stop channel for making chemistry simple, clear and exam ready. As I told you in my previous video that I am going to start from analytical chemistry, which is part A of paper 3, and this requires multiple concepts to solve the problem. That's why I am going to start solving these questions fast, and then we move forward to the another type of question in my upcoming video. So from I have chosen two problems from question paper that came in 2017, and these two questions are of 5 marks each, and you are going to give only space of a half page. You need to solve this question in half page, and I have taken the problem from classical quantitative chemistry, or we can say stereochemistry, and this question generally belongs to classical, or we can say pre-experimental analytical chemistry, when there is no sophisticated instrument available to find out that what is the composition of the solution, what is the concentration in that solution, and how reaction is going on. So they have used some chemical principles and calculation to determine this. So this type of question will have the question based on stoichiometry, equilibrium, redox reactions, complex formation, gravity, volumetrical analysis, or acid-base chemistry. So I have chosen two problems, just like I have told you before, from paper of 2017, and each question is of 5 marks. So the first question is a mixture of copper oxide, the mixture of cupric oxide and cuprous oxide with a mass of 10.5 gram is reduced to give 8.66 gram of pure metal. What are the amount of cupric oxide and cuprous oxide in gram in the original mixture? So what they have told you that in the initial state they have taken some X amount of this cupric oxide and 5 gram of this cuprous oxide, and it is giving you copper, which is 8.66 gram. You don't need to go into the balancing the equation and how this reduction has taken place. If you don't know, there is no worry. This question don't require that thing. This question generally requires a simple basic algebraic maths, where we are going to make two quadratic equation, and using that quadratic equation we are going to solve this problem. So as you can see from this question that mixture means copper of cupric oxide plus this copper oxide making a mass of total 10.5 gram, and here we have taken this as a X gram, here it as a Y gram. So we already have our first equation in hand. X plus Y is equals to 10.5 gram, or we can also convert it into 10.5 minus Y. This is going to be our equation 1. Now we have utilized this value already to make our first equation. Now we are going to utilize this value to form our second equation. But how to do that? For that we are going to use the smaller concept. Let's say its mass is 79.55 gram, and if you reduce it, it is going to give you 1 mole will give you 1 mole of copper, and its 1 molar mass is 79.55 gram, so its mass of 1 molar is 63.55 gram. So here we have taken it as X. Now X is what? 63.5 divided by 79.55 multiplied by X gram of copper. Similarly, you can also make this kind of reaction for this cuprous oxide. here it is, its molar mass is 143 gram, and here because we are getting two metals, so if we divide it, we will get it 127 gram. Similarly, you can find out the value of Y is going to be 127 divided by 143 Y gram, and if you further solve it, it is going to be 0.799x, and this is going to be 0.888y. Now this is the mass when we are going to have the full 1 mole of cuprous oxide and 1 mole of cupric oxide, if we have this mass. But here we are only getting what, 8.66 grams. So we can make another equation like this: 0.799x plus 0.888y is equals to 8.66 gram. Now you can put the value of x here, 0.799 10.5 minus y plus 0.888 is equals to 8.66, and if you solve it, you are going to find it like 0.799 multiplied by 10.5, it is going to be 8.3895 minus 0.799y, sorry, this is also y, plus 0.888. Now if you can, this is y, if you cut this here, you are going to get at 0.089y is equals to 8.66 minus 8.39, so it's going to give you value of 0.27, and y is going to be 0.089. So we divide it by 0.89, 0.27 divided by 0.089, it is around 3.034, and when you put this value of y in this equation 1, you are going to get the amount of x, 10.5 minus 3.034 is it going to give you 7.46 gram. And now we already know that why we have put this cuprous oxide as y. So this is cuprous oxide and this is cupric oxide. So this is how you are going to solve this problem, by utilizing simple algebraic equation. And the second question for today's video is this. It is basically from the solubility factor to a mixture of strontium 2 and beryllium 2, means there is a solution which has both strontium as well as barium. Na₂SO3 solution is added gradually, and then this solution is going to be added into the mixture of this solution. And what they are asking like, out of these two metal ions, which one is going to be precipitated first, and then they have given it the solubility of this ion. So for that we need to write an equilibrium equation like SR(SO4) in equilibrium, because ion and precipitation, they have precipitation generally occurs when the point reaches slightly up to the equilibrium value. Precipitation, they are starting, which is going to start first. So this is SR plus 2 plus SO4 minus 2. Here we know that Ksp is equals to solubility. This is going to be S, this is going to be S, and if this is also S. So same, one is going to give you the one strontium ion and one sulfate ion, and we already know the value of this S. And if you write this equation is like that, Ksp is going to be like that as strontium plus 2 and sulfate ion minus 2. This is the value of Ksp. Or we can say, if we put this value, it is going to be as a square, and we already have the value of this 2.8 multiplied by 10 to the power minus 7 whole square. And similarly for BaSO4, you can also make this equation like that, Ba plus 2 plus SO4 minus 2. This is going to be S, then it is also going to be S, and it is also going to be S. Here the Ksp is what? Again, this is going to be the square of 4.2 multiplied by 10 to the power minus 11. Now let's solve this. It's going to give you 7.84 multiplied by 10 to the power minus 14. And here 4.2 multiplied by 4.2 is going to give you 17.64 into 10 to the power minus 22. So from here we can see that the Ksp value of BaSO4 is, BaSO4 is very much less than the Ksp of strontium sulfate. Now how we are going to find that which one is going to be precipitate first? So here you need to know a very simple question, or you can put it here as in the answer sheet, Ksp increased, precipitation decreased. Okay, so whenever there is an increase in Ksp value, the precipitation is going to be slower down. But what they are asking? They are asking which one is going to be precipitate first. Means precipitation first. For precipitating out first means faster. For faster precipitation, Ksp should be decreased. And here we already know that the value of Ksp for barium sulfate is low, so BaSO4 is going to be precipitate first. So this is how you need to solve this question. So that's all for now. I have taken these two problems from Geochemist Exam 2017, and these both are of 5 marks question, and only half of the page is they are going to give you. Only you need to complete this within the half page, so write it like that and don't utilize the space in the question sheet. Generally you will find there is some space left on the left side, and right side is prohibited, so do not write your answer there. And I also want to give you one more advice, that for this question, for this things you can utilize the rough sheet, and in rough sheet you can use pencil because there is no extra sheet. For rough work the space is also very low, so use pencil so that you can rub it and you can use it again. And because due to using pen, it is going to be written, and when you overwrite it, you are going to be confused when you solve more problem, and it may be chance that you will put the wrong value. So that's for all now. So finally I would like to thank you so much for watching. If you found this video helpful, please hit the like button and share it with your friends. Don't forget to subscribe my channel for more updates on chemistry and exam guidance. Your support truly motivates me to create more helpful contents. Okay, see you in my next video. Bye bye.